Welcome to Design of Concrete Structure course. So today is lecture number 19. So till now we have covered the basics of earth-centric design, starting with material properties of construction materials. Then we have discussed about beam design, then slab design, column design, and in the last few classes we have discussed about how to design the staircases. So this is lecture number 19. Here we'll be discussing about the foundation design. So the foundation is very much important for any structure, because so till now whatever we have discussed, that is beam, slab, staircase and columns, which is actually placed above the ground level, are actually known as superstructures. The superstructures are on the top of the foundation, right, and designated as a substructure. So the structures above the ground level we call it superstructure, and the structure below the ground level we call it substructure. So the element of superstructure, the loads, moments, and its adjacent element below. So basically what happens, whatever loads are coming from superstructure, like from the slab to the beam, beam to the column, and ultimately column to the foundation, load goes. So from the superstructure, load transfers to the substructure, and through substructure or through foundation, basically the loads are transferred to the nearby soil. So thus, the foundation structure is effectively supports the superstructure. However, all types of soil gets compressed significantly, right? So whenever in the foundation, the soil will be compressed significantly and causes the settlement on a structure. So that also we have to take care, because the superstructure load is huge load is coming in on a foundation. So through foundation, the loads are transferred to the soil, nearby soil, right? So that's why we have to understand the soil behavior properly, because if because soil may have a settlement foundation level, and if the settlement happens, so this also will produce additional moment and for additional stresses on a structure. So ideally, so the if you have a column, and this column will be going, and then you have the foundation at the bottom, right? So if this is a ground level, so above ground level you have beams, columns, all these things will be there, right? So you have the beams, above beam you have some slab, so many more things will be there. So this is our ground level. So this top portion we call it superstructure, and this portion we call it substructure, right? And nearby this all are surrounding soils. So whatever load is coming from slab to beam, then beam to column, and ultimately column to foundation, and through foundation the entire load goes to the nearby soil, right? So that's why in this lecture we'll be designing, or basically we'll be understanding the theory part of design of the foundation. So this is the foundation part. So let's get started. So before we start our foundation design, let's see what our requirements we have. So that requirements of foundation, you will get it in the clause number 34.1 IS 456. So what are these requirements? So the foundation structure should be able to sustain the applied load, moment, forces, and induced reactions without exceeding the safe bearing capacity of soil. So what is safe bearing capacity of the soil? So the soil has a capacity of taking the loads. So after certain extent, soil cannot take more loads, right? So the maximum capacity of of the soil to take the load is called actually safe bearing capacity of the soil. So our foundation structure should able to sustain. So foundation means it includes footing as well as nearby surrounding soils. Okay, so that is a whole we call it foundation. So that is the primary difference between foundation and footing. So footing basically is the structural part where the concrete is used, whereas foundation is footing as well as the nearby soil, we call it foundation. So foundation structure should be able to sustain the applied loads, moments, forces, whatever is coming from the superstructure, okay, without exceeding the safe bearing capacity of the soil. So that is our first requirement. We will get it in this clause number. And second requirement is the settlement of the structure should be as uniform as possible. Means all the columns in a structure, there are multiple columns, right? If I draw a simple structure of a, this is a plan view, uh, and these are the different grid points. At different grid points you have one column. So here you have one column, in this point one column, here one column, like that you have multiple columns on a structure, right? So the uniform, so that this settlement if happens on the soil, so if the, so we should make sure the settlement is uniform settlement. It means all columns has settled the same quantity or same amount, so that we have to take care. If there is differential settlement, then this will cause extra forces on a structure, and which may fail. Because of that, structure may fail also. So the settlement of the structure should be as uniform as possible, and it should be within the limits, right? We will have some specific limits, so that settlement or should not be crossing that limit. So it is known from the structural analysis that the differential settlement, so as we discussed in the last structural analysis course also. So because of differential settlement of the supports, there are additional moments will be generated on a indeterminate structure. That's why we should avoid the differential settlement. Like all columns should settle uniformly, like same amount. Then there won't be any additional stresses on a structure. So there's the very good two requirements you have to maintain while designing the structure. So in addition to these major requirements mentioned in this IS code, we should take care about the stability of the structure also, because the foundation in a structure actually made at the first, right, at the beginning of any construction. So once construction starts, the first element we construct on a site is the foundation. So after foundation, we make the columns, beams, slabs, like that. The process goes. So our foundation should be also, we have to take that the stability of the structure is maintained. There should not be any overturn on a structure. So that also we have to take care. So, however, it is worth mentioning that the design of foundation structure is not like simple beams, columns, and slabs, because here in the foundation design we have to take some extra precautions also, right? So, as we discussed in the last class also, that staircase design, it is just combination of beams and slabs and columns, right? This is the three basic elements which we discussed earlier. But design of foundation is not as simple as a staircase. Means we have to take care about other parts also, because the foundation is basically the substructure. Means it goes below the ground surface. Below the ground surface, there will be actually soil structure interaction also. So foundation structure actually undergoes the soil structure interaction. Means soil will be there surrounding, and then you have the structure, right? But superstructure, there is only structure, there is no soil all around. But here the foundation is actually covered on a soil, so that soil structure interaction will be there. So that also we have to take care very much additionally in this point. So the next one we have to additionally take care is the accurate estimation of all types of loads, moment, forces are needed for the present as well as the future expansion if applicable. So that also we have to take care, because foundation is as I mentioned, that the first part we make foundations and it is below the ground surface, right? So now in future, if you want to construct and you want to increase the floors, but you cannot increase the foundation, because foundation is one time you have made it. Okay, so that's why while constructing the foundation, you have to make sure that all the loads coming from the structure has to be taken care. If the structure is designed for the 15 story, then you have to design the foundation also for the 15-story building. Like maybe at the present day you constructed 5-story, but the foundation should be considered while designing up to 15-story. Okay, so all these estimation of loads, accurate estimation of loads are very much important while foundation design. So next another difficulty in foundation structure is, though it is underground, it in so although the foundation structure is actually below the ground surface, right? So there is no architectural aesthetics involved in the structure. Okay, so that is also another thing, that there is no architectural design. Number four, or the another difficulty you will find, is actually foundations are in direct contact with the soil. So in the soil there will be so many chemicals, right? Chemicals will be there, so these chemicals will react to the concrete. So that also we have to take care while designing the foundation. The soil structure, I mean, the soil structure interaction will be there, as well as the foundations will be subjected to chemicals, have chemical attacks and all. So that also we have to take care. And the last important thing is very much important, is the maintenance of the foundation. So it is very difficult for to undergo the maintenance of the foundation, because it is under the ground. So we can but beams, columns, so it is exposed to the environment, right? So that we can do the maintenance after a few years. We can repair some portion of the beams, columns, whereas foundation, the maintenance is not at all possible, because it is buried in the ground, and it is very difficult. So basically these are two requirements foundation has to be followed, and as I mentioned, there are five disadvantages also, or we have to take extra care about these 5 points while designing a foundation. So now let's see the different types of foundation. So primarily the foundation is classified into two categories, that is shallow foundation and deep foundation. So which one is shallow foundation? As we understand, shallow means what? The which is, depth is very less. So based on the depth of the foundation, we classify the foundation in two types, right? One is shallow foundation, another is deep foundation. It means if foundation is very, shallow, means very low, then we call it shallow foundation, and if the foundation is very deep, then we call it, as simple as it is, deep foundation. So again, in the shallow foundation also we have multiple divisions. So shallow foundation, first one is the plain concrete pedestal footing. So this is first type of shallow foundation. And then second type of foundation is isolated footing. Then we have combined footing, footing, strap footing, strip foundation, and the rough or mat foundation. So this is the typical 6 different classifications of shallow foundation. So depending on our requirements, we either choose the plain concrete or the isolated or combined. So depending on our condition, our situation, we can choose any one of these foundation type in case of shallow foundation. And in the deep foundation, we have only one type of foundation, that is the pile foundation. What is pile foundation? So pile foundation is very deep foundation. If the soil bearing capacity is very low, then we go with deep foundation, right? If the soil quality is very good, like in Hyderabad, the soil condition is very good. So you can see the bedrock is very near to the ground surface, and in some position, the bedrocks are actually exposed to the ground surface. So because of that, soil quality is very good, then we may not go with the deep foundation. So shallow foundation is also sufficient in that case. But if the soil quality is very poor, if you have, so much sediments on the soil surface, like, in the Gangetic basin in North India, so there you will find the soil quality is a little bit poor. In that case, shallow foundation may not be the ideal option. If you want to construct a multi-story building, then you have to go with deep foundation. Okay, so up to the bedrock level, you have to take care. I mean, you have to expand the foundation. So these are the different types of foundation. Now we'll see in details about each of these foundation. So the first foundation type is basically the plain concrete pedestal foundation. So what is plain concrete pedestal foundation? So this is actually a plain concrete pedestal footing or foundation is actually very economical for the columns of small loads or the pedestrian without any longitudinal tension reinforcement. You can see here this type of pedestrian footing we can use when the loads are very less amount of loads are coming, then we can go with plain concrete pedestrian footing. We have not provided any reinforcements in this footing. If you see, the entire foundation or the footing is made up of only concrete. There is no reinforcements at all. So when we go with plain concrete pedestrian footing, when the loads are very less, when the loads are very less, then only we'll go with plain concrete foundation. So you can see there is no reinforcement, right there. So this angles is we can make depending on the footing type. We can choose the angles also. Now in the next category of footing is the isolated footing. So these footings are for the individual columns having the same plan, forms a square, rectangle, or the circular as that of the column, preferably maintaining the proportion and the symmetry so that the resultant and the applied forces are, reactions are coincide. So what does this mean? Isolated footings are basically, so if you have multiple columns, right, so each column one footing at the bottom we provide, right? So this is isolated footing. So for example, if I draw a plan of a structure, so this is the plan of a building, and you have multiple beams and columns are passing. So at every grid point we provide the columns, right? So we have the column here, we have the column here, so all the grid points, one columns are there. Okay, so each column will have a different footing, right? At the bottom, each column will have individual footing, so something like that. So something like that, each column will continue and the end, so this type of footings will be there. So this type of footing we call it isolated footing. So and we provide the reinforcement also. So you have the column reinforcement passing, and you have the we have to provide the reinforcement, that is transverse reinforcement, longitudinal reinforcement in the column, in the footing itself. So isolated footing may be this type of simple square type, or maybe you have the circular isolated footing or rectangular. So depending on the column, basically, if you have a column is a rectangular column, then not mostly we provide the footing also a rectangular footing. If the column is circular column, then we provide the circular footing. isolated footing depending on the shape of the column. So you can see this is a plan view. So this is the portion of the column, and this is the entire footing. So you can see that this is simple rectangular footing. So there may be some other types of footing also. Sometimes we provide the step footing also. So step footing means the column will continue, then this type of step. So something like that footing also we make. Okay, and we have the reinforcement here at the bottom. So this is also a isolated footing, and this is a step footing, right? So similar to the step side, we provide the reinforcement, and this is, we call it step footing. So this is step footing, step isolated footing we call it. Or sometimes we can provide the footing something like that also. So we can have an inclined portion, something like that. Something this type of footing also sometimes we draw. So this is also isolated footing. So the main objective here is basically each footing will be one separate, right? Here one footing, here or each column will have one different footing, and each footings are actually separate to each other. So isolated footing we provide when the loads are coming, moderate loads are coming, and we have the sufficient space, we can easily put each column one footing, then we go with isolated footing. Now in the next category of footing is a combined footing. So which one is combined footing? So combined footing means basically when the two columns or the when the two columns are very near to the each other. So in many cases this may happen that when two columns are very adjacent, and it is very difficult to provide the isolated footing in each column. So in that case we combine both the footings and we make a common footing, that we call it combined footing. So for example, if I draw a structure, a plan of a structure. So this is one grid point, another grid point, something like that. If you have unsymmetric, pattern of plan, and every grid point you have one footing. This is one column, this is another column, this is one column, this is another column. So now you can see that these two footings are very close to each other. That's why it may be very difficult to provide the isolated footing here and here. So what we do, we combine both the footings. Okay, so that is, we call it combined footing. So when the spacing, basically when the spacing between the two columns are very close to each other, then it is very difficult to provide a separate isolated footing. In that case we go with combined footing. Basically we overlap the areas of the footing, right, and we draw it. So combined footing means basically footings of the two columns. Basically combined footing normally means a footing combined of two columns. Okay, such footings, either it may be rectangular footing or it may be a square footing, whatever we can go with depending on our structure. So you can see this is a plan view. So this is one column, this is another column, and the footing is here combined for the both the columns. Okay, so maybe if a structure is very near to the, you have to construct a structure and you have the boundary line here, right? So in that case, maybe you may have to provide the two columns very nearby. So maybe combined footing is a good idea for that. So now the next category of footing is strap footing. So what is strap footing? So strap footing is basically when two isolated columns are combined by a beam with a view to sharing the loads of the both the columns by the footing. Then this footing is, we call it strap footing. Basically here we have the two footing, isolated footing basically. So this is one footing and this is another footing. But we connect both the footings with a beam. Like if you see, this is in the plan view, same diagram in a plan view. So you can see plan, this is one footing, this is another footing. Okay, so because of some constraint, maybe this side, the boundary wall is here. So although you may need very longer footing area, but because of the boundary wall, you cannot extend this footing. Okay, so that's why the footing size here will be reduced. Whereas here, this is the middle of the structure, so you have the larger area for the footing, right? So, but here because of some region, we cannot increase the foot foundation size. So whatever loads are coming from this column, so some load will be distributed to the nearby support here through this beam. We call it strap beam here. Okay, this is called strap beam, and the two columns, the isolated footings are basically connected through a beam, and that beam we call it strap beam, just to take care about the sharing of loads. Okay, because maybe this footing also may require larger area, but because of some constraint we cannot increase the footing size. Then we can make it as a small footing, but some portion of the load can be transferred to the nearby footing through a beam, and that we call it strip beam, and this type of footings we call it strap footing. Okay, so now the next type of footing is actually strip foundation or the wall footing. So wall footing means all along the wall, basically wall will act as a footing. So that is basically, I know, basically this is a long strip where especially the load bearing capacity masonry wall, whatever loads are there, walls are there, that wall is directly transferring the load to the ground. Okay, so this is very long type of wall you will find that wall is directly transmitting the load to the nearby soil. So that this type of footings are very strip, right? Looking like a strip manner, very long it will be. This is a plan view, you can see this is the entire length of the footing. So this is also the strip footing we call it. And then the last type of shallow foundation is the raft foundation or the mat foundation. So what is raft or mat foundation? So when the soil bearing capacity is very low, so in that case you may go with either deep foundation or we can go with mat foundation also. What is mat foundation? So the entire plain area we excavate, and what we do, we we provide a slab at the bottom. So entire area of plant is excavated, and then we provide a inverted slab. You can imagine we at the foundation level we construct a slab. So from this slab basically columns are coming out. So these are plus are basically columns. These columns are directly coming out from the slab. So you have a base for the entire foundation, and from the base basically these footings are coming up. So these footings are actually called raft or mat foundation. So when we go with raft foundation, when the soil bearing capacity is very low or the load of the superstructure is very high, in that case we may go with the raft foundation or the mat foundation. So in nowadays, if you go in new constructions, there in the city, you will find these are all high-rise buildings. So there will be mat foundation at the bottom. So entire area is excavated, and then we provide the slab, inverted slab at the bottom, and from the slab, basically these columns are coming up, and this we call it a raft foundation. Okay. So these are the different types of foundation. These or whatever detail now we have discussed all at the shallow foundation. Means foundation level is very not deep, maybe within few meters from the ground surface if you want to draw. So now we will be discussing about the deep foundation. So what is deep foundation? So deep foundation means if the soil bearing capacity is very low, means the bedrock is at the very depth, very deep, from the ground, and you have the sediments deposited at the soil surface. So in that case, we go with deep foundation. So you can see this is a plan you can imagine, and deep foundation means we construct these piles. We call it pile foundation also. So this small foundations we make, and we increase this type of columns basically we make, and these columns we call it pile. So this length of the column may sometimes go up to 20 meter, 30 meter, depending on the soil condition. If the bedrock is at the very deep, then we have to increase the pile up to that bedrock. It may be 25 meter, 30 meter deep we have to go. So you can see, so this is the foundation, right? This is a foundation. This is a cross-sectional view. So from this, so you can imagine this is an isolated footing, and we have this type of small, columns are going at the bottom up to the bedrock 20 meter, 30 meter deep. So you can imagine an entire 7-story, 8-story building height that much go. You have to go deep, and this pile we have to draw it. So it is very difficult to construct the piles because you have to dig, you have to make the holes from the in a ground, and then you have to pour the concrete. Okay, and then all the piles are connected on a base that we call it pile cap. Okay, all piles are connected, so this is pile cap, and then you have the column. So column will be coming up here. So this type of foundation we call it pile foundation, and when we go with this type of foundation, when the soil bearing capacity is very low. So now we have seen different types of foundations, and based on the ground quality, means based on the soil properties, if the soil is very good, then we'll go with shallow foundation. And again, what type of which location the footings are there, either you may go with isolated footing, or you may go with strip footing, or a strap footing, whatever maybe, depending on the loads, we can go with different types of shallow footing. But if the soil quality is very bad, then we have to go with deep foundation, and then we have to make the piles and all, and we have to construct the structure. So now one very important definition in the foundation design is the safe bearing capacity of the soil, right? So our main objective of the foundation is basically to transfer the load from the structure to the nearby soil, right? So soil has some capacity limitation. Soil cannot take more loads also. So we have to find it out. So basically geotechnical engineers, their role is basically to find it out what is the bearing capacity of the soil. So what is bearing capacity? So in that bearing capacity, we are finding out how much maximum load the soil can take. Then we call it safe bearing capacity of the soil. So the gross and the net capacity are the two terms used in the design of foundation. So the gross bearing capacity is the total safe bearing pressure just below the footing due to the load of the superstructure as well as self weight of the footing plus weight of the earth lying on the footing. Okay, that is we call it gross bearing capacity of the soil. And on the other hand, net bearing capacity is basically gross bearing capacity minus the pressure due to the overburden soil. So we have to compute the bearing capacity of the soil. If the bearing capacity of the soil is very low, then we have to go with the dimension of the footing will increase. Like you need more areas to transfer the load. But if the bearing capacity of the soil is very high, then you in a small area only we can transfer the load. In that case, the dimension of the footing also will be reduced. So based on this capacity, soil bearing capacity, our structure, our foundation we have to design. Now next is what is the depth of the foundation. So the depth of the foundation, so as per our IS 1080-1962 code, it is mentioned that the minimum depth of the foundation, at least it should be 15 centimeter. So that is our minimum criteria as per our IS 1080. Minimum 50 centimeter, anyway we have to provide it. So at the to start to beginning for the designing, so we have the formula called Rankine's formula. So to find it out what is the initial guess for the depth of the foundation, that we can find it out using this formula. What is D? D is basically depth of the foundation, and QC is the as I mentioned, this is the gross bearing capacity of the soil, and phi is the density of the soil, and and the sorry, phi is the angle of response of the soil, and the gamma is basically density of the soil. So if you know the properties of soil, then we can start with any initial estimation of what could be the depth of the foundation using this Rankine formula. Okay, now let's see what are the design consideration for this for the design of concrete, for the design of foundation. So the first design consideration we'll see is the minimum nominal cover. Cover means now already we understood it. In similar thing we have the beam design also. So let me draw a foundation here. So if you draw a isolated footing, so this is isolated footing, and we have the reinforcement at the bottom, right? And this distance we call it cover. COVE, cover. Okay, so this distance we call it cover. So what is the minimum dimension of cover? You will get it in this clause number 26.4.2.2 IS 456. So the minimum nominal cover for the footing should be more than that of the other structural element of the superstructure, because we provide that cover for the beams as well as in the column in the slabs. Everywhere we provided the cover, right? But for the foundation, the cover will be maximum. Value of cover will be maximum. Why? Because the foundation is surrounding soils will be there, right? So because in the soil there will be many chemicals will be there. So that chemical may react with the reinforcements what we provide, and our reinforcement may get corroded and all. That's why we have to provide very high cover in case of foundation design. So as per our IS 456 clause number 26.4.2.2 prescribed, the minimum cover is actually 50 for the footing. Minimum 50 we have to provide it. Okay, because any many harmful chemical effect we can avoid to the reinforcement. This is our first thing, that is nominal cover. Now the next thing is thickness of the edge of the footing. Means at the edge of the footing means this is edge of the footing, and how much spacing we have to keep here. So that you will get it in this clause number 34.1.2 IS 456. Okay, because the minimum thickness, the edge of the reinforcement at the plain concrete footing shall be at least 150 as per our IS 456. Minimum 150 we have to provide this gap. So that 150 value you will get it in this clause number, this one. Okay, on a soil at least 300 above the top of the pile footing. Okay, as per IS 456. Okay, now you understand this one. Now the third consideration is calculation of bending moment and shear force, because in a foundation also load may come directly axial load. If the load is axial load coming, then there won't be any bending moment. But if the loads are coming in an eccentrical manner, in that case the foundation also may be subjected to bending moment. So that to get to come to get for the calculation of bending moment, you will get it in this clause number For 34.2, what is the different bending moment directly you can use from the clause itself. Then for to compute the shear force, you will have this clause number 31.6 and clause number 34.2.7456. You will get the in the shear force. So in the shear force, there are two types of failures you will find in the concrete in the foundation. One is one-way shear, another is two-way shear or the punching shear. What is one-way shear? One-way shear means, for example, you have a slab here. So if you have isolated footing, let's imagine you have isolated footing. So at the center you have, so this is a column and this big rectangle is the footing, right? This is the column and big one is the rectangular footing. So now what will happen? Because of excessive load, the failure may happen about only one axis. So failure may happen here. So this portion may go down and this portion may go up and this entire portion may go down. So the failure happened here. So this type of failure we call it one-way shear failure. Only one side the failure happened. So in that case, what is the shear force that you will get it in this clause number. And another type of failure may happen in the foundation that we call it two-way shear or the punching shear. So in that case, what happens? The failure may happen about both the axes also, right? So this entire portion, the column will try to penetrate into the foundation. So this entire portion will go below the foundation. So this failure happens in both the direction. That's why the name is also two-way for punching here, because this entire column will punch the this entire footing, and this type of failure we call it two-way or punching shear failure, and that value we will get it from this clause number. Then for the bond and anchorage, you will get it in this clause number. Tensile reinforcement means this is the tensile reinforcement you have to provide at the bottom. Okay, and then transfer of loads from the base to the column, because the loads also has to be transferred, right? So loads are coming from the column like that, loads are coming, and ultimately these loads are basically transferred to this longitudinal line for longitudinal bars, right? That's why we have to provide proper anchorage here also, proper anchorage here. There is the transfer of load at the base of the column, that also we have to take care, and that you will get a clause number 34.4. And lastly, we have the final consideration, that is the nominal reinforcement minimum. We have to provide it 34.5. There we'll find what is the minimum reinforcement in any case you have to provide in a foundation. So that is as per our clause number 34.5.1. You will find the minimum reinforcement you have to provide. Okay. So these are the different 8 design considerations for the design of foundation. So now we'll see the distribution of base pressure. Now we understand entire load, whatever structured loads are there, loads are coming to the column and columns are resting on this foundation, and this foundation will be transferring the load to the nearby soil, right? So depending on the soil type, basically the loads are transferred. So if the soil is sandy soil, means the sand, more sands are there on a soil, then this is the distribution of pressure you will find. If the soil type is sand type, then this is the distribution of the soil pressure. So at the center of the footing, you will have maximum pressure, whereas near to the edges, pressures are reducing. Whereas if the soil is clay soil, then the pressure will be coming something like that. So depending on how much pressure is coming, we have to design the reinforcements here. So for this type of distribution of load, we have to design one type of design, and this type of load we have to design another type of foundation. So depending on the distribution of pressure, we have to design. Okay, so that's the basic overview of the foundation. So in the next class, basically we'll be designing a foundation from the basic scratch, and these are the whatever design consideration we have considered. We'll use all the design consideration. We'll use the different clauses for the different parameters, and ultimately we'll complete our foundation design. Thank you.